Hello, Travis Chamberlain here of Noodle Pros. I'd like to demonstrate a problem for you. It's an SAT problem. It's got a lot of words and it uses percents, and it's a pretty difficult algebra problem. So I'm actually going to show how to sidestep the algebra and use a technique called plugging in. We should be able to plug in and solve this question within 2 minutes. I'm going to take a little bit longer because I want to show how to annotate. Annotation is really important on a text box question because it's going to have a lot of pieces, and what you want to do is take all the pieces out of the text box, have them on the outside, and be able to solve without having to look back at the text box. If you have to go back into the text box, you can get lost in it and misplace a small detail. The first time I tried to solve this question, I actually flipped town M and town N. That took quite a while to get out of and figure out my mistake. So let me show you how not to do that. The sales tax is calculated using the formula T equals SR. Always write down your formula, always label it. T is the tax, S is the cost, and R is the rate. T is the tax included in the cost. The cost of a product before tax in town M is X dollars. Okay, so we're in town M, and X is the before cost. And we're in town N, and it looks like they're saying in town N that the cost of the same product before tax is Y dollars. So Y is going to be the before cost in town N. The tax rates in M and N are 6% and 8% respectively. Looks like a good spot. Let's put 6% here and 8% here. I want to show something about the rate. If the tax rate is 6%, 6% means we're actually going to have a multiplier of 1 plus 6 over 100. In other words, we multiply by 1.06. If you go up by a percent or down by a percent, what you can do is take the original and go 1 plus or minus the percent over 100 and multiply to find the final. This relationship is something that all test takers should know. The final cost is equal to the original cost times 1 plus or minus the percent over 100. So using the same equation, if we've got an 8% tax rate, that means that we're going to multiply by 1 plus 8 over 100. So the tax rate is actually, as a multiple, 1.08. There we go. Now we've got our tax rates so that they match with this formula that was given. The other piece of information they say is that if the cost of the product in town M after tax is 16 more than its cost after tax in town N, then which expression describes X in terms of Y. So what they're saying is that the final cost in town M is going to equal the final cost in town N plus 16. Okay, we have all of our pieces of information. Quick pause. At this moment, you could try to solve this algebraically. Those of us that really like math are probably going to feel compelled to do so. However, I would say that the majority of us are going to feel a little bit intimidated by all of the algebra here. There are lots of equations. How do we put them together? How do we relate X and Y? Have no fear. Because we have variables in the answer choices, what I like to call the VAC, because we've got X's and Y's, we can plug in. About 90% of the time, if you've got the VAC, you can plug in. Let's plug in for X. And because we're using percents, let's use the most obvious number for percent, or per 100. Let's use X equals 100. If X equals 100, then MF is going to equal 100 times 1.06. Why? Because T equals S times R. If X is the cost and R is 1.06, then the final value of MF is going to be 106. If you add 6% to 100, you get 106. Let's figure out what Y is. Well, actually, we can't yet, but we can figure out what NF is. NF is going to be, well, let's see. MF is NF plus 16. So MF is going to be 106. NF is going to be NF. And we're adding 16. Oh, so NF is 90. Okay, now we can figure out what Y is, because NF is going to equal Y times 1.08. Again, that's using the same formula that we established up here. Given that we want to find the final value after tax, the original cost, which is Y, times 108 will give us that after-tax value. So NF is 90. 90 equals Y times 1.08. We can do a little bit of long division over here, and we can figure out what Y should be. We don't have to figure out exactly what Y is, but we can do a little bit of math and estimate what Y is, and then check our answers. Don't forget you have to move your decimals over, so this should become 9,000. And we can say, how many 108s fit in 900? Well, definitely less than 9. How about 8? Do some math here. I think that's 864. That'll give us a 3 and a 6. Bring down the 0. How many 108s fit in 360? Looks like 83-ish. Let's just stop there. So we have a relationship. When X is 100, The y value is 83. That's what y is. So we've actually plugged in and solved the entire problem now. What we can do is check answers and see which of these two values gives us the right answer. So when x is 100, we want to see which value is going to correspond given that y is 83. Well, 108 times 83, that's going to be like, I don't know, 8,500-ish. I mean, it's going to be a little bit more than 8,300, right? And if we add 1,600-ish, that's going to be like 10,000-ish. And if you divide 10,000-ish by 100-ish, notice how we're just estimating, that looks like that comes pretty close to 100. That's a good-looking answer. Given that that's a good-looking answer, if we were to take the same thing where we went 108 times 83 for y, and we were to subtract 1,600, and then divide by a much bigger number like 160, that's going to become much smaller. That cannot be the right answer. We know that just by looking at the structure of the expression, not the right answer. What about 108 times 83, this time minus 160 divided by 106? That's still going to be smaller than A. That's likely not the right answer. Same thing with D. If we go 108 times 83 and we subtract 1,600, which is even smaller than C, that's definitely not going to be the right answer. Okay, if you were still not quite sure you had the right answer because there is kind of a closeness between C and A, you could check. You could actually do a more careful bit of math and figure out that, oh, well, it's definitely the case that A is closer to 100. What did we do? We put everything on the outside, so we don't have to read it anymore. T equals SR. X is before cost at 6%. Y is before cost at 8%. We used a bit of outside knowledge that everybody should know. Final equals original times 1 plus or minus percent over 100. And we also wrote down that the final cost in M is 16 more than the final cost in N. At the point that we had all of our information written down, we plugged in. We solved for X, we substituted for X, and then we solved for NF, and then we solved for Y. We had to do a little bit of division. We didn't go all the way out into the decimals. We just knew that Y was 83-ish, and then we could see which answer came closest to 100. That would be a great way to proceed without a calculator. Is don't forget you can plug in, and especially with a percent question, you can plug in 100, and the math is not going to be that difficult. Take care.